Okay, hi everybody. Here are Chapter 3 notes. Depending on which class of mine you're in, we've all kind of ended at different spots, so you may have to jump around to one of the other videos to kind of find where we left off in class. Sorry about that for now, but I'm assuming once we, for the next Chapter 4, everyone will kind of be more on the same page. So I'll try and name the videos so that you can find where you're at. Hopefully a little easier, but you might have to poke around a little. Okay, so Chapter 3. We're all dealing with probability. These notes do also include Section 3.5 at the back. Okay. So the first thing we talk about is, well, just briefly mention, we throw this word out a lot, random. We have some sort of an idea of what random means, but a little more formal definition is that an event is truly random if each outcome has an equal chance of occurring. And this chance of occurring, that's what we're studying now. That's our probability. Okay. So what do we mean when we say probability? Exactly what is it and how do we calculate it? Sort of an informal definition that I think we're probably used to is that it's the chance or likelihood that an event is going to occur. A little more formally than that is the probability is the predicted long-run relative frequency of an event. Okay, that means that if we did something over and over and over many times, the probability of the event is the proportion of times we actually saw the event occur. Just consider this. Suppose we are flipping a coin. Let me spell it right. Flips. And we're looking at the number of times we get heads. Okay, so if we were to flip a coin 100 times, we would expect half of them to be heads, 50%. Okay, so we'd expect 50 heads. Now we know that we're not going to get exactly 50 heads. We'll probably get a little more, a little less. Let's just say I get 58 heads. Okay, well, if you look at the percent that I get heads, the relative frequency, 58 heads out of 100, that's going to be 58%. Okay. Now let's say we increase the number of times we flip the heads. Okay, again, over the long run, wherever it said that predicted long run relative frequency. Let's say I flip the coin 1,000 times. Again, I would expect roughly half to be heads, so that'd be 500, but I know I wouldn't get exactly 500. I'd get a little more or less. Maybe I'd get a little less. I'd get like 400 and, I don't know, like 95 or 92. Well, if you were to calculate the relative frequency, that'd be 49.2%. Okay, let's go it up a little more. Let's say I were to flip a coin 10,000 times. I would get close to 5,000, but give or take some, maybe I would get 5,100 heads. Well, that's 51%. I'm just making these up off the top of my head, but what you can see is that the more times you flip, the closer the probability is getting to 50%. Maybe not in this case. I should have thought about that a little better. But that's the idea here. It's the long-run relative frequency that we would expect to happen if you were to do an event over and over and over and over. Okay. So some definitions here. The first thing we're going to define is an outcome. An outcome is one possible way that something can happen. So for example, if we're flipping a coin, then landing on heads is a possible outcome. So is landing on tails. An event is an outcome itself or a collection of a set of outcomes. So for example, if you're rolling a die, then rolling a 1, 2, 3, 4, 5, or 6 are all the possible outcomes that can occur. And if we were to create an event, like say my event would be, the event could be roll an odd, or an even, they say. Rather an odd, sorry. An event would be maybe a sub-collection of all those possible outcomes. Okay. Now the sample space, that's real important. This is something we're going to want to come back to a lot and use a lot. The sample space is the set of all possible outcomes that can occur. So this right here was the sample space. When you're rolling a die, that's your sample space. That's what can happen. You get a 1, 2, 3, 4, 5, or 6. We're going to see that calculating probability becomes much easier if you can figure out the sample space. Where probability gets tricky is the sample space gets hard to calculate or inconvenient to calculate. All right. So how do we calculate probability? Let's just say that A is some event. Maybe it's rolling an odd number. Maybe it's rolling a 3. Maybe it's whatever. Flipping a coin and getting heads. Well, the way you calculate probability, the probability of any event, is the number of outcomes in that event. The way I think about it is the number of ways to succeed at that. So I would say success over the total number of outcomes that are possible. So I just divide it by all outcomes. Some people say it differently. They say, it's what we want over what's possible. You find a way to say it to yourself to remember that probability is, again, the way I say it is it's the total number of ways I can achieve success at that event divided by all the possible outcomes that I could have done. All right, so let's take a look at a basic example. It says, suppose we roll a 6-sided die. List out the sample space. Well, again, we said when you roll a die, the only numbers that can come up on that die are 1, 2, 3, 4, 5, or 6. That's it, right? That's the sample space. That's every possible outcome that can happen. So if I want to calculate the probability of rolling a 1, there's my event, rolling a 1. Well, again, probability is the number of ways I can succeed at doing that divided by all the possible outcomes we have in our sample space. So the number of ways I can succeed at rolling a 1, well, there's only one way to do that. It's to get the 1. So there's one way to get a 1, and there's 6 possible outcomes that could happen. So the probability of rolling a 1 is 1 out of 6. The probability of rolling an odd, how many ways are there to succeed at rolling an odd number? If I count the odd numbers in my sample space, I have 1, 2, 3 odd numbers. So there's 3 ways to pull off a win, to succeed at getting an odd number, and there are, again, 6 possible outcomes available. So the probability of rolling a die and getting an odd number is 1/2, 50-50. How about the probability of rolling a number less than 5? Be very careful with the wording here. Less than 5 means I'm not going to include the 5. So in terms of my sample space, I'm only talking about those numbers, right? Isn't that the way to win? If I want to find the probability of rolling a number less than 5, there are 4 numbers less than 5. So 4 out of 6, again, divided by 6 possible outcomes, would be the probability of rolling a number less than 5. I would reduce that to 2/3. And lastly, they say, what is the probability of rolling a number greater than 6? Okay. Looking at my sample space, how many ways are there to succeed at that? How many ways are there to get a number greater than 6? There's no ways to do that, right? There's no numbers in my sample space larger or greater than 6. So those 0 ways to pull off a win or a success out of 6 possible outcomes. So you have a 0% chance of rolling a number greater than 6. Okay. Here's another example. It says, suppose there are 300 people sitting in the theater. 210 of them own an iPhone. If a person is chosen at random, what is the probability that that person chosen owns an iPhone? One thing I really want you guys to do is do not just write an answer. Use proper mathematical notation. In other words, tell the reader what the heck this number represents. So I would write this as, I'm looking for the probability of someone that owns an iPhone. Just use that probability notation. Okay. Well, they said there's 300 people sitting in the theater. So that's my total number of outcomes. If I'm going to pick someone at random, there's 300 people to choose from. How many ways are there to pull off this win? A win would be you picked someone that owned an iPhone. Well, it says that 210 of them own an iPhone, so 210 would be the number of ways to succeed at that event. If you simplify this down, you get 7 out of 10, or 0.7, or 70%. Remember, relative frequency, probability, it can all be expressed as a fraction, decimal, or percent. They're all correct. Okay. I hope you're getting a decent sense on how to calculate basic probability. It's weird because probability itself is really easy to calculate, or it's not too painful. Again, it's what we want over what's possible. The number of ways to pull off a win over all the possible outcomes that are there. What gets challenging is as the rules of the game change, it becomes harder to create a sample space, and that's then what makes probability hard to do. Because if you have your sample space, you're literally just counting up, again, the number of ways to win over all possible outcomes. Okay, so we're going to take a look at something a little different, but just very slightly. We're going to talk about a probability distribution. We've talked about frequency distributions in class. Remember, the idea of frequency distribution was you list every possible outcome that can occur, and then you list the count of how many times each of those outcomes occurs. We've actually already looked at probability distributions too, because really it's the same as like a relative frequency. It's just over the long run. So in a probability distribution, here's the two things you list. Every possible outcome that can occur from the random event. Okay, like your sample space. That's all it is. Tied to each of those outcomes, we also list the relative frequency in the long run of performing each outcome, which is, again, the probability of pulling that event off. So we have two basic rules that we must abide when talking about a probability distribution. So two things are going to happen. One is that the sum of all the probabilities will always add up to 1. Okay? In a probability distribution, the probabilities sum up to 1. And the next thing is that all probabilities themselves must be positive. So let's take a look at a probability distribution. We're going to build one right now. Probability distribution. Okay, so here's the event. We're rolling a die, and we want to list all the possible outcomes. Remember, we first list all possible outcomes that can occur, and then the probability of each outcome occurring. That's how we calculate or write out a probability distribution. So what can happen when you roll a die? You can roll a 1, 2, 3, 4, 5, or 6. The probability of rolling a 1, we said out of the whole sample space, there's one way to get a 1 out of 6 possible numbers. Same for a 2. There's only one way to get a 2 out of 6 possible numbers. And one way to get a 3 out of 6 possible numbers, and so on. Each of the probability of getting either of these numbers is 1/6. But what you have is now a probability distribution, right? We've listed all the possible outcomes that can happen, as well as the probabilities of each outcome. Okay, I see that I'm running out of time on my 15-minute video here. I'm talking too much. I'm going to stop it here, create a new video, and I'll pick right back up with the next one. Alright, see you in a minute.